10.2. Today we'll be talking first about how to solve an equation like this. So to do this, we're going to use a technique that we did last semester called the U sub. We're going to let u equal root x, because that would mean that x is u squared. So now I get u squared minus 10u plus 9 equals 0. Let's factor. At this point, let's plug it back in. So the root of x should equal 9 or 1. So clearly x must be 81 or 1. So pretty easy, not too hard. Let's try with a little bit harder question. So in this problem, I can see that u should equal t to the 1/3, because that would mean u squared is t to the 2/3. So u squared plus u minus 6 equals 0. We're going to factor. So u would equal -3 or 2. Now we're going to plug it back. So t to the 1/3, that is the cube root of t. That's -3 or 2. So t must be -27 or 8. So pretty straightforward here, nothing really crazy. However, these can be tricky, so we're going to put a sidebar. Note, be careful with even roots. Meaning you might get a situation where you get x to the 1/2 equals -1. A lot of people would just square this and get 1 as the answer. However, you want to write it as a root. That's why I wrote it right here as a root, so it's easy to see. If you write it like this, it becomes more apparent that a root of a number can't be negative. So that's impossible, and this would be no solution. However, note that if it's an odd root, that is possible, right? We could take the cube root of -27, for example. But if it were like x to the 1/4, again, that can't be a negative number like that. So make sure you add this note to your notes here. Okay, let's try an advanced log problem. F of g of x, we gotta find that. Okay, so let's plug it in. F g of x is 2 to the x. Okay, let's plug that in. So 2 to the x into log base 2. I'm gonna move that x over. So x times log base 2 of 2. And notice how that's nice, and that cancels. Answer must be x. Now as for the domain, so luckily we wrote it in a pretty nice way. Domain here I can see is all real numbers, and the domain at the end is all real numbers. Therefore, the domain for the entire composition is simply all real numbers. Let's do B. We switch it, g of f. So g of f is log base 2 of x. All right, let's plug it in. So g is 2 and to the power of log base 2x. We can see that this is the sandwich property. Let's cross it out. And we get x. Now for domain, a little bit trickier. This one we can see it's from 0 to infinity. Clearly that one is everything, which means the domain of the entire composition is those two things put together, which would be 0 to infinity. Okay, let's go to part C. F of g of 3. So plug in 3 to A, and I can see that would just be 3. If you plug in 3 right here, you just get 3 back. Not too hard. Letter D, f of h. So h is 4x. So that would be log base 2 of 4x. The domain of the original part, that's just all real numbers. Domain of this part, 0 to infinity. So the domain of the composition, let's put those two things together. Got it. Now we're on the final part. F of h of 8. So we're going to plug in 8 here. F of h of 8. That's log base 2, 4 times 8. Log base 2 of 32. So ask yourself, 2 to what power makes 32? That is clearly 5. Okay, now we're on the final part. So in these problems, you're going to see the instructions are express y as a function of x, and you often see that on the SAT. Simply translated, that means solve for y in terms of x. So our answer should be y equals. And for your notes, this is what you want to write down. Natural log x equals natural log y. Our conclusion is x equals y. And this is the main concept we're going to apply to all these questions. You want to be in this situation to be able to get rid of all these logs. So a common mistake people do is they just cancel out all the logs. Can't do that. That doesn't fit this, right? We need it to be a single log equals a single log. So the left side is okay, natural log y. The right side, we got to combine all these logs. So that would be natural log x, c on the top, because I can see there's a positive, and 2 is on the bottom. And now I'm in this situation we outlined right here. So we're going to come back here, basically take those out. So y equals xc over 2. There's our answer. Next one. This is kind of tricky because it's so different from the last one in a sense that there's no log here. So we're going to do a little trick. We're going to introduce a log. We're going to use the fact that natural log e equals 1 to help us here. So definitely write this down. This will help you on the homework problem. We're going to rewrite this as 2x times natural log e. And this is 1, so that is allowed. Now the whole point of this is because now I can grab this 2x and I can hairball it back up there. So now I have natural log y equals natural log e to the 2x minus natural log c. Now let's combine it using our log property. And we cancel the logs out. So y equals e to the 2x over c. Answer. Now for our final example here. This is a bit of a doozy, but we can do it. We're going to definitely want to hairball all of these to make it easier. So natural log y to the 5th equals natural log 3x plus 1 to the 3rd minus natural log x. Notice how it's x to the 1 because that 1/2 will take out that 2. Then plus natural log c. We're going to leave the left side alone and push the right side together. So 3x plus 1 to the 1/3 over x times c. And then we're going to cancel these logs out and we get this. Y to the 5th is equal to 3x plus 1 to the 1/3 times c over x. And then finally we're going to raise everything to the 1/5 power. And when we have our answer, 3x plus 1 to the 1 over 15 times c to the 1/5, all divided by x to the 1/5. And then we circle that, and we are done.